Hello scholars, welcome back to the channel. We're going to be continuing our look at the linear graph. This time we're plotting an equation that has a positive variable. So if you want to know what happens when we plot an equation with a negative variable, just check that other video that was done. Same linear equation with a negative coefficient. Here we have a positive coefficient, a positive 5. And we're going to see what happens there. So, this is our equation. It's already in the format that we want it. If it was not, as similar to what we did in the other video, it was not in the order that we wanted it with y equal to everything else. So we had to put it in that order. This time, we are given the equation the way we want it. Y is equal and everything else on the right. Okay. So this is our domain. This tells us which x values we're working with, where we're focusing on our graph. From -4 to 4. That's called the domain. So our x values will be from -4 to 4. And when we're doing a linear equation, we really only need 2 points to join them because linear equations produce straight lines. I like to throw in the 0 just to see what's happening in the middle here, right? I like to throw in the 0 in the mix. So the 2 endpoints of the domain and 0. Now the equation tells us what are we to do with our x values in order to get our y values. Because what we really want are our ordered pairs of coordinates in order to plot them on the Cartesian plane, the coordinate plane, so we'll get our graph, so we see what the line is doing, how is it behaving. So we're going to multiply each x value by 5, and then we're going to add 7 to get our y value. Okay, so let's go then. So 5 times -4, that's -20. 5 times 0 is 0. 5 times 4, that's +20. And we're adding 7 to each of those. -20 plus 7, that's -13. 0 plus 7 is 7, and 20 plus 7 is 27. So now we can write our ordered pairs, our x value and y value for each. So -4 on the x goes to -13 on the y. -4, -13. The x value is written first, then the y value. 0 on the x, 7 on the y. And 4 on the x, 27 on the y. So these are our ordered pairs of coordinates that we're going to plot. We're going to move on the x, then move on the y and put a point. So let's rule up our coordinates plane, our Cartesian plane, based on the scale that we want. Alright, so let me show you what this would look like on a real graph paper. The real coordinate plane. I've ruled this up, so this is my x-axis, my horizontal x-axis, and I've decided to use a scale of 1 centimeter to 1 unit. So these are my positive x values and my negative x values going in opposite direction from 0. So from 0, 1, 2, 3, 4, 5, 6. From 0 this way, -1, -2, -3, and so on. On my y-axis, positive y values above, negative y values below 0. The scale I've decided to use on this particular graph, I've gone up by 5 on the y-axis, right? Now on this graph here, we might have to go by 5 on the y-axis also because our biggest y value is 27. On the x-axis, we're only going up to 4, so we can spread out our scale on the x-axis. We can go 2 centimeters to 1 unit. And let's put in our arrow and our x, our arrow and our y to name the axis. Maintain that same scale on the negative x-axis, 2 centimeters to 1 unit. So every 2 little boxes on the graph paper, you would have 1 unit. I can't do that on the y-axis because I would not get 27, it will go off the page. So I have to use a different scale on the y-axis. I'm going to use a scale of 1 centimeter to 5 units. So for each little box, I'm going up by 5. 5, 10, 15, 20, 25, 30. Same scale on the negative. So 5, negative 5, negative 10, negative 15, negative 20. Alright. So now we're going to plot our coordinate pairs. Negative 4 to negative 13. So negative 4 on the x goes down to negative 13 would be about there. So where negative 4 meets negative 13, that's where we put our point. Not just at the negative 4. Where the negative 4 meets the negative 14, that's where we put the point. 0 to 7. So 0 on the x, going up to 7, so that's 5, 7 is there. And 4 on the x to positive 27 on the y. So 4 on the x up to 27 on the y. So on the graph paper, your readings will be accurate because you're going by a scale that's already ruled up quite nicely for you. I'm using the board, so I'm doing some estimation. It's not going to be perfectly straight, right? But hopefully you get the idea. So I am going to draw a straight line. So you would use your ruler for this. I don't have a long ruler for the board. But connecting the 3 points, I'll get a straight line. And what I'm going to do, I'm going to write my equation. Y equals 5x plus 7. And I've completed my graph. Now I'm looking to see what orientation is it. It's inclined that way. See, it's inclined that way. So when the variable, when the x or the y or the p, whatever your variable is, in a linear equation you'll have one variable. The variables, you'll be able, even if it's more than one, you'll be able to combine them because they should have the same power and the highest power should be 1. So just x or just p or just w. So it will be inclined like this. When the variable is positive, this is how it's inclined. When we did the graph in the last video and the variable was negative, it was inclined that way. Right? It was inclined like that. Also, the number at the end is called your Y-intercept. That constant term at the end, it tells you where the line will cut the y-axis, where it will intercept the y-axis. So 7 is at the end, see it cuts the graph, it cuts the y-axis at positive 7. So you can know a couple of things just by looking at your equation even before you plot it. Just looking at this, I know how my line would be inclined. It's going to be inclined that way because I have a positive coefficient in front of my x term, in front of my variable. I also know where the line should cut the y-axis. It should cross the y-axis at positive 7. So if I were to plot my graph and these two things did not happen, that would indicate to me that I did something wrong in my calculations. That's how you can just have a good idea, are you on the right track? Your graph should cut the y-axis, whatever this number is at the end, the constant number, your y-intercept. That's where your line should cut your y-axis. If your x-coordinate, coefficient, the number in front of your variable, is positive, your line should be going that way. Whether it starts over here or down there, it should be going this general direction. If your x coefficient is negative, it should be going the opposite general direction. That's the orientation. So those are at least two things you can tell about what your linear graph will look like just by looking at the equation. You don't even do anything yet. Just looking at the equation, you should know that much. Alright, so that's it for plotting the linear graph with a positive variable. Check that other video where we did a negative variable and compare the orientation of the line. And also check the videos that we'll be doing on the quadratic equation, plotting the quadratic graph where the variable is negative, where the variable is positive, and so on. Check that also so you can make your comparisons. Alright, so if you have benefited from this video, just drop a line in the comments and say thank you, miss, and just share the video with as many persons as you can so they can benefit just like you did. Alright, if you haven't yet subscribed, just do so now. Click that bell also so you will be notified. And if you want me to do a video on any topic that you're struggling with or you just need some clarification, just let me know in the comments and I'll do that for you. Okay, scholars, take care. I'll see you in the next video.